Okay, again, friends, we are going to begin our lesson, specifically lesson 5 on multiplying by 0, 1, 2, 5, and 10. Now, does anyone have a prediction as to why we are starting with those factors? Why would we start with those factors? Why wouldn't we start with, say, 7? Multiplying by 7 or multiplying by 8. Why would we want to start with 0, 1, 2, 5, and 10? And I'm seeing Odin's hand. Go ahead, Odin.
Because they're the easiest to multiply.
Thank you. Yes, and you're exactly right. Those are the easiest factors to multiply. Why? Because we are so familiar with our work with addition and using number lines and forward counting or skip counting by 2s or 5s or 10s. Remember, friends, thinking about what we've learned about multiplication so far and what it is and what it can do. Multiplication is simply adding together equal groups. So when we start going a little deeper into this unit and we talk about multiplying, it is going to be much easier to model certain things like equal groups, arrays, forward counting on a number line with numbers that you're already familiar with in doing this repeated addition. We've all skip counted or forward counted by 2s before, and 5s before, and 10s before. And we've all learned about the concept of zero, and the absence of value, no value. 0 means no value. Is it an important digit in our number system? Absolutely. That absence of value is very important, particularly when we take it back to place value, right? And we talk about how zeros can sometimes be placeholders for us in a certain place. So for example, in a number like 405, we have no 10s in that number, but that 0, that absence of value in that place is extremely important. So we're never going to ignore or discount our friend, the 0. It is a very important digit. All right. So that being said, we are going to be going a little bit deeper now in our knowledge of what multiplication is and what it can do by using the numbers of 0, 1, 2, 5, and 10. So what I'm going to do is I'm going to share my screen and I'm going to go over a couple of pictorials with you for review, and then we're going to get started. All right. So let me see here. Okay, friends, so as a review, I wanted to put this pictorial back up on my screen so that we can get our math vocabulary, we can get that part of our brain working this morning, all right? So again, friends, to review, a factor, if you can see up at the very, very top of this pictorial, a factor is each of the numbers you multiply together. So for example, 4 times 5. 4 is a factor, 5 is a factor. Factors are the numbers you multiply together. A product, of course, is the answer to a multiplication problem. 4 times 5, that product is 20. And then a multiplication sentence, it's a math sentence made up, of course, of at least 2 factors, and it has an equal sign in the product. 4 times 5 equals 20 is a multiplication sentence, or you will also see it as a multiplication equation. All right, and then down at the bottom, of course, where it says factor times a factor equals a product, that's putting words to a multiplication sentence or multiplication equation. Factor times a factor equals a product. Now, something else I would like to share with you, and I'm sorry, my screen is being really slow this morning. And so ways to show multiplication, if you're looking up at the screen, you are going to see this pictorial that is also on the walls in our classroom. Take a look at the top left where it says equal groups, of course. That is a model of 3 times 4 equals 12. You will see that you have 3 equal groups of 4. Going to the right, that same equation is modeled with repeated addition. 4 plus 4 plus 4 equals 12. Going down to the lower left, you're going to see that number line where you are doing hops of 4 or forward counting. You're going to see it in many different ways. CJ, thank you. So you're going to see the number line going from 0 to 4, 4 to 8, 8 to 12. You're going to have those 3 hops of 4, and then taking it to the lower right quadrant of the pictorial, you're going to see the array where you have 3 rows, 4 columns, or 3 equal groups of 4. This pictorial, my friends, is basically a review of the entire last chapter, a last lesson of your math work. Now we're going to go forward. We're going to go a little bit deeper into looking at multiplication with 0, 1, 2, 5, and 10. So, want to take a look at page 105 now. So what I am projecting right now is page 105 in your textbook. So up at the top, it reads, previously, you learned about the meaning of multiplication. This is going to take a closer look at certain multiplication facts. So we're just going to use what we know to try to solve this problem. Now, friends, it is talking about Jenny. Jenny draws 6 cartoon bugs. Each bug has 10 legs. How many legs did she draw? Now, friends, again, going back to our close read strategies, this is not something that we're going to be able to solve until we know what the question is asking and we identify the important information to help us get there. All right? So when I close read this question, I am seeing that there are going to be 6 cartoon bugs with each has 10 legs. All right, and what I need to know, the question is asking me, how many total legs? That is my question. CJ, I want to see you following along, please. Thank you, my friend. All right, so when I'm taking a look at this, I know that I am going to have 6 groups. I'm going to have 6 groups. How do I know that? Because that's what the problem is telling me. I'm going to have 6 equal groups. So that's a good place to start. That's a good place to start. So I'm going to have 1, 2, 3, 4, 5, 6. All right, I know I have my 6 equal groups. But how many are in each group? Well, the problem also tells me that. They have 10 or 10 legs because apparently I'm drawing bugs. Each bug has 10 legs. So I get to draw my bugs. Here we go. All right. So what have I done? I have given each of my bugs or groups 10 legs. 10 legs. So to help my brain, instead of counting all those little legs, what I can do with my bugs is this. I can say this one has 10 legs, and this one has 10 legs, and this one has 10 legs, and so on until all of my equal groups are identified. All right? So then it's asking me, how many legs? Well, look what I get to do. It's either skip counting, repeated addition. I could do a multiplication equation. There are lots of things I could do here. If I did repeated addition, what's it going to look like? It's going to look like this. 10 plus 10 plus 10 plus 10 plus 10 plus 10. And of course, that sum, right? The sum of that repeated addition is 60. And if we want to take it that next step, you're going to identify what that 60 actually is. And you're going to tell me it's 60 legs. Not just 60, it's 60 legs. Another way that we can take a look at this, we could say 10, 20, 30, 40, 50, 60, right? We skip count. Another way we could take a look at this is we could say that we have 6 equal groups of 10. And of course, we get a product of 60 legs, which matches our sum from the repeated addition. So the important piece here, my friends, is looking at these strategies in which to solve these particular problems. There are many ways to do it. Understanding what multiplication is an important piece in being able to develop these strategies. Okay? So friends, on page 106, I would like you to take a look at question number 2. Question number 2. And here I am, right here. It says that you can show and solve multiplication problems in different ways. We know that. And so one way to find products when multiplying with 2, 5, or 10 is to use that skip counting, and we just saw that. So let's take the problem from page 105 a little bit further. So let us say now that Jenny draws 8 cartoon bugs with 10 legs each. So what we want to do now is to show how you could use skip counting to find the number of legs Jenny drew. So going back to that strategy of labeling and identifying, right? We know that we could go back and start labeling, and we could say 10 and 10 and 10 and 10 and so on. So of course, in using skip counting by tens, we would say 10, 20, 30, 40, 50, 60, 70, 80. Now, what we could also do to help our brains here, we could go back to our little cartoon bugs, and we could say 10 plus 10 plus 10, and so on, until we get to the end and come up with that sum. If it helps you to use the bugs like a number line, you could do that too. And you could start with that 10, 20, 30, 40, 50, 60, 70, and 80. You could do that too. And so in applying a multiplication equation or a multiplication sentence to these new 8 cartoon bugs, of course, we could say that we have these 8 bugs now. There are 10 legs on each bug, and we come up with a product of 80 legs. And of course, that product will match our repeated addition. Give me a quick thumbs up if we're following along. Quick thumbs up, please, friends. Awesome. Good job.